All right, quick disclaimer. So I guess what I'd like to talk to you about today isn't a technical presentation. What we're going to talk about is our journey from, I guess, in the exploration space from 2015 through to the present day. And I guess some of the key learnings from that exploration period in our life and Chris, Ian and Rob's life, and hopefully we can impart some knowledge onto you guys. Because it's not overly technical, we do have a table down the back with some rocks and we're happy to talk to anyone in more detail if there's anything of interest out of this presentation or just generally. So just quickly, the business, we've got two operations, Krakow and Tritton, JV with Helix at Cambaligo, and the blue dot without any text is the Torrens JV with Argonaut. We're in the process of morphing into a bigger company with Round Oak Minerals, and I haven't put those assets on there, and it's not really relevant for this presentation, but so obviously we're focusing on the Tritton operations for the next 20 minutes. Oh, there it is there. So just very, I guess, high level, so we're just going to frame the problem, talk about the strategy framework, executing our exploration plan, some high-level key learnings from our exploration, and then a little bit our Constellation Discovery and what we've got planned going forward. So, framing the problem. So just I guess a bit of background about Tritton and exploration. Tritton's it's a highly prospective tenement package. Been a lot of exploration done within the tenement package, sort of dating back to the 70s. People in this room have worked there well before I have, done a lot of amazing work in the tenement package. And I guess one of the keys is that we have a number of deposits traced along our 45k strike corridor, which is within a kilometre of an outcropping sandstone unit, which we call the Budgery Sandstone. So we had a level of understanding where we thought the prospective corridor was between Budgery in the south and Avoca Tank in the north. Obviously we've got a 1.8 million tonne per annum processing plant, so every day we're chewing up 5,000 tonnes of copper ore that we need to replace. Tritton deposit was first mined in 2005 and is still going, and it's a phenomenal mineralised system with, as you can see, over 400,000 tonnes of copper mined there to date. Interestingly, most of the exploration is south of the Mitchell Highway, which is that diagonal black line running up through there. But there's a tremendous data set south of the Mitchell Highway, which, I guess to distill it into three is really a whole bunch of ground-based EM surveys from the mid-90s to the late 90s, and vacuum and RAB surface geochem samples, which have been tremendous help for us in our understanding and how we should tackle exploration. Probably the key take-home point on this slide, and I guess to contextualise where we've come from since 2015 is the last point. So in a climate where we weren't making a lot of money, there wasn't a lot of money for greenfields exploration, and whilst we were drilling brownfields drilling at Avoca Tank and Currajong in the 2012-2013, weren't doing a lot of greenfields exploration, and the philosophy really was that just keep the tenements in good standing with minimal spend. So obviously that's not conducive to finding anything. So the business, this is, I guess, the critical point in 2015, and really, I guess, the change in philosophy for the company. Aeris, I guess, changed management, well, Straits at the time in around 2012. New management really, I guess, operations focused, big on running the mine, Brownfields exploration is obviously important. Have an appetite for greenfields exploration, but to be fair, probably didn't really understand what that meant. We did a resource definition drill program at Tritton in 2015, and the mineral resource was below expectations. Grade was dropping at depth. We're already mining below 1 kilometre, so it was pretty tough. In that metal environment, we weren't making much money at all. So that meant we had a 5-year life of mine plan at that point in time. So effectively, what we quickly figured out was, well, we need to replace Tritton. Tritton, as you can see on the graph, is our biggest deposit. The red dots it's a log probability graph. Red dots are where our different deposits relate in terms of tonnage. So obviously most of them are 5 or less than 5 million tonnes. Tritton is 25, probably 30 million tonnes. The next biggest is Murrawambi at 15 plus million tonnes, and then it sort of slides off. So we effectively said, well, ideally what we want to do is find something big. Something big is really plus 10 million tonnes. And if we are lucky enough to find it, then it's probably going to be 4 years to get it into production. So easy to say in terms of the vision, difficult to execute, and the clock was ticking. So how are we going to go about doing this? So I guess just to go back on the previous slide, minimal greenfields exploration, company that's more operations focused. We needed to, set our exploration values and get buy-in from the executive team and the board. So, not dissimilar to what a lot of people do in this room. So the obviously priority target size was plus 10 million tonnes. And I guess we coined the phrase, we want to explore in new spaces. So in our view, there's no point exploring either geographically in areas that have been explored before or to similar depth horizons that have been explored before. If we're going to find something big, it has to be in new ground. And I guess the graph there from John Hronsky is, sort of helping to support that, where early on, exploration, greenfield success, you're generally going to find larger deposits. Brownfield success is great, but generally it's going to be smaller tonnage, incremental increases. And then a clear demarcation between greenfields and brownfields. Whilst we've got a pool of money and we're drilling and doing stuff, we need to make sure that we're still doing our greenfield strategy and we're not getting distracted spending more money on resource definition drill programs. And we needed a commitment of 5+ years with a consistent funding model to allow us to do what we needed to do. And obviously, exploration is a science, as we all know. It's non-linear, and you don't really know where it might take you. So having that understanding from the board and the executive team that in 10 months' time we might be deviating, doing different things, doesn't mean we don't know what we're doing. Things have changed. And then obviously selecting the right tools for the right job. So really, to distill that, what we're saying is we need patience and trust. It's trust between the technical teams and then obviously up to management and board and then also down. And we also need some money. So the exploration reset, broadly we split it into two halves, and that was divided by the Mitchell Highway. South of that, a lot of historical data. We had a pretty good understanding of where we should be exploring, close to the Budgeree Sandstone. There had been some regional mapping done north of the Mitchell Highway. We weren't 100% sure on whether the same rocks were continuing. So EM has been used a lot in the past, as I touched on, between 95 to 98. A lot of Sorotem EM surveying done, which is, the blue polygons that you can see there. And Tritton was found via Sorotem EM back in the 1995. It's a blind deposit, about 180 metres below surface. Most of the other deposits have a surface expression. So I guess our appetite was to explore the EM space and see whether we could use that going forward. And the graph is really sort of, I guess, dividing our known deposits into, I guess, conductance ranges based on the sulfide textures. So most of them are conductive, obviously varying tonnage sizes, and we also have a couple that aren't conductive. And just to very quickly, what are we exploring for? We're looking for pyrite dominated with lesser chalcopyrite, plus or minus pyrrhotite. Generally they're stacked lens, but can be one large system, which Tritton is. Long down plunge component, dip varies from 30 to 75 degrees. Our deposits are still open at depth. Strike length, which is really important, varies from 50 metres to 300 metres, and in my mind that's how I guess I discriminate between a large shoot, well, large deposit and a small deposit, is based on the strike length. And that's, I guess, an important assumption that we use to drive our exploration in the preceding 2 or 3 years. And obviously located close to the Budgery Sandstone unit, with the exception of Currajong. So what did we do? Well, we said we're going to explore between Budgery and Avoca Tank using ground-based moving loop surveys. That's roughly about 40k strike kilometre. And ideally we're looking for Tritton-sized deposits. So we're going to space out our moving loop surveys at 300 metre spacings, and yeah, cover a crap load of ground with moving loop EM. We did some, I guess the cool thing with EM is you can do some forward modelling and kind of justify what you're doing and make yourself feel good that the forward modelling sort of supports your theories. The graph here is interesting in the sense that the solid lines are 300 metre strike length deposits with varying conductance levels. So the blue is 200, I think that's 500, and that's 750. So obviously higher conductance, and that's depth below surface here. So higher conductance, obviously you can see a lot deeper. Solid black line is roughly the noise level. What we're saying is for Tritton and our conductive bodies, they're generally sort of 100 to 200 Siemens. So we're sort of looking at that solid black line to around sort of 500 metres. Interestingly, if you halve the strike length, then the depth of detection quickly drops off. So essentially what we're doing is we're tailoring the moving loop survey to really only find Tritton and Murrawambi, and ignoring Constellation. But you can see the strike lengths of most of the other deposits is a lot less, and we're not gonna find those in this survey. Actually, I might have skipped one. Did I? No. Okay. We, as part of the survey, we obviously trialled it to make sure it was going to work. The Currajong deposit was a known sulfide system, conductive to sort of around 400 metres below surface. We trialled the moving loop survey there. We initially had the sensor within the loop, but there was so much conductive cover that we couldn't actually see the response from the sulfide mineralisation. So we trialled a few things and ultimately used a sling ram setup where the sensor is 150 metres to the west of the loop, just to get it far enough away that it's not as influenced by the conductive cover. It can actually see any bedrock response, which worked. Incidentally, we also trialled the survey over Avoca Tank, and you can see the strike length of Avoca Tank is quite limited to around 50 metres. It's quite steeply dipping. We ran the moving loop survey over that and didn't even see a response, and that's massive sulfide. So I guess it's the aerial extent of the sulfide expression does dictate whether you're actually going to see a response, irrespective of if it's massive sulfides or not. So we did over 8,500 moving loop surveys in the following sort of 2.5 years, and for people who haven't been involved in moving loop surveys, it's a lot. And I guess to distill some of the learnings, I guess if I'm exploring in the Jura-Lambo Basin and I'm using moving loop techniques, combination of moving loop and fixed loop, if the geophysicist says there's a bedrock conductor, then I think there is a bedrock conductor. It's either going to be graphite or sulfides, and the conductance will dictate the degree whether there's pyrrhotite or not. If there's pyrrhotite, we'll be looking at sort of conductance ranges above 1,000. If there's no pyrrhotite, then it's probably going to be sort of maximum of 200 Siemens. Petrophysics was important. Our assumption was that banded and massive sulfides would be conductive. After the petrophysics, it was just massive. And we had a couple of false positives from the moving loop, which is that image there. This is a moving loop EM anomaly through here. It's a couple of k's north of Tritton, so a great spot. The process was to, I guess, validate that with a follow-up fixed loop EM survey. We were pretty convinced that this was going to be the next discovery. Did a fixed loop survey. Results didn't quite sort of match, because this is a B field sensor, so I've got the three principal components. One of the components wasn't sort of matching up. So essentially what we did was we were moving the loop sort of either side of the conductor, and I guess what the response should be, and then obviously depending on the amount of conductive cover, it will either sort of prove that it's conductive response or it is actually a legitimate bedrock conductor. So we did a series of those, and ultimately we had I guess this model here where we had conductive cover and some IP effects in between those to, I guess, generate the moving loop anomaly. So it can be a little bit tricky. And outside of that, we were completing regional mapping on the northern half of the tenement package. Do we have the same rocks? Yes, we do have the same rocks. Okay, simplistically, southern half, or south of the Mitchell Highway, 40k strike length along the Budgery Sandstone, 750,000 tonnes of copper. We've traced the Budgery Sandstone 105 k's north of the Mitchell Highway, little exploration. Well, why can't we find more stuff there? So our exploration focus advanced to the northern half of the tenement package. Just out of interest in sort of that sort of light green colour, that's the moving loop survey area. We flew two airborne EM surveys, which is the shaded grey, over the course of a year, one SkyTem, one VTEM. So through the course of that project, we, as most of you guys and girls know who fly airborne EM surveys, you generate a lot of anomalies. I think we had 400 plus. Steve Hind, Alex and Jess sort of whittled those down to the top 20 over sort of 3 or 4 or 5 months period, which are the blue and red asterisks is shown there. Of those, the strategy was to complete one moving loop line to confirm whether it was an actual bedrock conductor or not. If it kind of looked like it was, then we'd do adjoining moving loop lines either side. Of those 20, we whittled it down to 2. One of those was anomaly M here, which was a known bedrock conductor, was drilled in, I believe it was the late 90s, hit some graphite, so was obviously considered not to be sulfide related. And then there was another one, anomaly KRM, I can't remember, I should remember, right on the northern margin of our tenement package. And we did two moving loop surveys as, I guess, abutting our tenement package, and the geophysicist said, well, actually this looks like it is a legitimate bedrock conductor. Can you do another line further north? And we're like, actually, no, we can't. We're at the end of our tenement boundary. I guess this leads into the discovery. So the top image there is the SkyTem signal response. That sort of blue line there, and there is our tenement boundary. There are our initial two moving loop lines there. And I guess, one comment I'd make is that obviously there's luck in finding a deposit, and I think this kind of illustrates it reasonably well. If we weren't able to fly that line there, if we could only fly that line there and our tenement was a bit further south, then we obviously wouldn't have found Constellation. So we did those two lines. We could see that there was something building to the north, and then we had to wait sort of 7 months to apply for the tenement. Thankfully, no one else had the tenement to the north. We got that granted in June. A little bit of a wait to get the moving loop team back out on site. Did 5 lines, and then had 2 bedrock conductors. This one was a lot bigger plate, sort of 300 by 300. Conductance is around 100 to 200, which is kind of in line with what we expected. And the dip was 30 to 40 degrees to the southeast, which kind of lined up with what we thought the plunge direction of the mineralised system should be. And then there was a smaller plate, which is this one, really high conductance, and it was subvertical. I remember talking to Chris about this, and I'm not embarrassed to say that there was a discussion around whether maybe it was a shaft and there was a Valiant car body down there. So first 2 drill holes, test each of the bedrock conductors. This is the first hole here, hole number 1, almost 20 metres at 2.4%. I can't remember the exact figures, but geophysicists planned the hole and said, you'll hit the conductor at, say, 195 metres, and we hit it at sort of 199 metres. So, I guess it does. If you've got low noise and you are getting a reasonable response, you can sort of model them quite accurately and I guess have some confidence in the plates. Ian Bailey went out to the rig, started shift, sent an email. We've hit sulfides. We could see visible chalcopyrite in it, some stringer chalcopyrite, which kind of looked visually sort of greater than 2% copper, so that was fantastic. But I guess reflecting on the petrophysics that we'd done, it kind of looked, it's probably a bad photo, but it kind of looks massive, but there's silica in and around the pyrite grain, so I guess acting as an insulator. So from the petrophysics work, it probably wasn't the conductive response, which gave us hope that there'd be some more. And then I think sort of in the afternoon, Ian reported that we'd hit the massive sulfide zone to the deposit. And then hole 2 was a lot shallower. We hit supergene mineralisation at 3.5 metres downhole. And then that, I guess, escalated into a much bigger drill program there. Again, without getting into the technical details, just some high-level points. It's a big deposit for us, obviously sitting in on a lot of porphyry presentations yesterday. Big deposits for us is in that 10 million tonne range. Why? Because that's 10 plus years mine life out of this asset for the mill. Strike length is around that 300 metre mark, so yeah, it's similar to Tritton. Down plunges around 1.1 k's. We've still got downhole at EM plates that we haven't tested. Starts from 4 metres below surface, which is kind of blows our mind when we go out there. It's in a topographic low, so it wasn't outcropping. Really well developed oxide and supergene horizon 2, which is great to see that in diamond core going through those horizons. Regional setting. The team have been doing a lot of work in understanding the deposits and what they mean, why they're forming where they are. There's a strong structural component to the story, and going forward, it's playing a role in helping us understand where they are and why, and obviously focusing our exploration in more detail going forward. And proof of concept. It's probably the biggest one for us is proof of concept. I mentioned 105 k's of geology continuing, and we've jagged something, so there's a lot more ground to try and find something else to support Constellation. And where to from here? So I guess reflecting on the work that we've done, we've made a discovery which is fantastic. Let's make the next one. How are we going to do that? The way I reflect on it is we've done a whole bunch of EM work through this part of the corridor, looking for 10 million tonne deposits. Does that mean we can't find anything else? No, it doesn't. There's definitely 2 to 5 million tonne deposits. They can be conductive or not, and we're doing systematic surface geochem through those areas now, I guess, is our next tool to follow up on what we missed with the regional moving loop survey. And then obviously going north, airborne EM survey through the rest of the area, and then follow up with moving loop and surface geochem. That's the last slide. I guess in closing, just thank the past and present geos who've worked on Tritton, getting us to where we are today. Big thanks to the team in the room today, and if you do want to follow up and chat to them, feel free. And big thanks to the resource definition team who aren't here today, who are working on getting their mineral resource out for next month. If they virtually watch this in the next couple of weeks, they should be logging core and modelling, not on YouTube. Thank you.